guys, let's go ahead and get started with our dynamic analysis demo. So first off, before you do any dynamic analysis, you want to check your config, make sure you're in a good state. There's a video on that. I'll put it in the notes for this video. So go back there if you haven't. Another thing you want to make sure is that you already have a snapshot. You do not want to detonate malware in a VM with no snapshot, or you're going to end up wasting all your hard work. So given that those things are done, we'll go ahead and get moving. So you're going to want to launch some tools. The first one we're going to launch is Process Explorer. It's from Sysinternal Suite. All the tools that you use, you're going to want to run as administrator. This lets them see a little bit more, and you want them to see as much as possible. Next, we're going to launch Procmon. This is another tool from the system from Sysinternals. Procmon, when it launches, takes off running. So we're actually going to stop that by clicking the magnifying glass and then click the eraser to clear what it had captured. I'm going to let that stop spinning before I go on, lest I crash something. Alright, the next tool we're going to launch is RegShot. Again, right-click, run as administrator, and we'll just set this right here for now. And then let's go launch our tools in Remnux. Your Remnux might look a little bit different than mine. This is an older version, but same concepts. So I already have inetsim running. The only thing that we need now is Wireshark. If you didn't have inetsim running, you can start it just by typing inetsim, enter, and then we will start capture. All right. Now we're just about ready to get going. We're going to take our first shot with RegShot. Again, RegShot takes two snapshots of the registry at two different points in time and compares them. So what we're going to be doing is taking a snapshot, running our malware, then taking another snapshot. Now we'll go ahead and launch regfs notify. It's one of the last things I launch because it's just a command line tool. It starts logging as soon as you run it. So again, run as administrator. And then last, I'm going to start Procmon by clicking the magnifying glass, and then I'm immediately going to double click my malware. And so over here in Process Explorer, we can see things blinking, indicating that some stuff is happening. You can see evil.exe here. Seems to have Adobe Update as a child. And people like to ask, how long do you let your malware run? And I usually, on my first run of a sample, will let it run a few minutes. If I learn something while doing more detailed analysis that makes me want to run it for longer, then I'll come back and do that. This sample, I pretty much know exactly what I'm waiting for with this sample. Also, while you're running your malware, move your mouse around, change which window has precedence, maybe type some stuff in Notepad, make yourself look alive. Alright, so that's good. So I'm going to stop capture by clicking the magnifying glass. I'm going to kill regfs notify with Control-C. And I'm going to take my second shot here in RegShot. I'm going to come over to Remnux, and I'm going to stop capture in Wireshark by hitting the red square. Back over here, I'm going to hit compare in RegShot. And these are our registry changes. I personally really hate Notepad, so I'm just going to open all that in Notepad++. And let's go get our regfs notify log. So a very common question is, where do I find it? regfs notify logs the same directory that it's located in. So in my case, regfs notify has its own folder in C tools, and so the log is in that folder with it. And so I'm just going to open that log also with Notepad++. Alrighty. So let's take a look at what we can learn from each of these tools. We're going to start with regfs notify because it's one of the quieter log sources, meaning it has less noise than some others. That doesn't mean it doesn't have any noise, but it's a little easier to start with. So I'm going to make this a little bigger, turn on wrapping, and let's take a look at what we see. So first off, this right here is weird. App data local temp is a location that anything can write to. It's not protected. And so a lot of software, not just malware, will use it to put temp files and installation files and things like that. But seeing a randomly named file written to that location while I know malware is running, that's enough to make me want to look into that. So what I'm going to do is I'm just going to make a separate document of things of interest. So as we scroll down, we see the prefetch file for evil.exe. We know we launched it, so it's not that interesting. But prefetch files are useful forensic artifacts for after-the-fact type deals. This is interesting. System32 is a protected location. Things shouldn't be writing there very often. And then seeing DLLs getting dropped while you're executing malware is a very big red flag. So I'm going to put this in our interesting things file. So let's see. These files indicate that sysprep launched. I'm going to put them over here because I don't know if you noticed or not, but while we were running our malware, if you were watching in Process Explorer, sysprep was actually in the execution chain. So I'm curious what was up with that. We're creating a new folder in app.localtemp and dropping an executable into it named Adobe Update. I didn't ask Adobe to update. I don't even think I have Adobe on this machine. So that's certainly also suspicious. Let's see, we have some artifacts that indicate some network activity is occurring. Lots of prefetch files for CMD, Rundle, conhost. It looks like we're trying to get a file and we're writing it into a temporary internet files location. It looks like this happened several times with several different file names. So I'll put this block into the interesting things block. Again, more artifacts of sysprep, a prefetch file for sysprep indicating that it executed. Ooh, that's even more suspicious. We delete cryptbase.dll. It's one thing to be writing DLLs, it's a whole other thing to be writing them and then deleting them. All these prefetches for the pings. Oh, we deleted evil.exe. Classic malware move. Put your next stage on host and delete yourself. More indications that we're trying to pull something. And that's it. So something a lot of people ask me after I demonstrate this is, how do you know what's malicious and what isn't? That takes a little bit of time. When I teach longer classes, we have a lab called No Normal, in which I have my students turn on all their dynamic analysis, all their monitoring tools, and just maybe open a web browser, type some things in Notepad, create a Word document, and then look at what logs that creates. And that's a good first step in getting to learn what normal looks like. It's really hard to recognize what evil looks like when you don't know what normal looks like. A lot of the answer, though, is just time. Time and repetition, and you'll start to get an eye for what's evil and what isn't. All right, so we have some things of note here. Some files were written and then deleted. We see that Adobe Update got dropped, which I believe we still see executing over here. So before I forget about Process Explorer, I'm notorious for forgetting about Process Explorer. Let's go take a look at what we could do with Process Explorer. So this is the process I'm most interested in. We can right-click Properties and view all sorts of information about this process. Where is it located? What command line was it launched using? If it has any auto start locations that Process Explorer can find. Don't take that as ground truth. One of my favorite tabs here is Strings. You can see the image strings. This is the same thing that you would get if you ran like strings in Linux. But what's really interesting here is the memory strings. When you click memory strings, you're actually dumping the strings from this process's memory space. And sometimes you can get some strings that don't exist on disk. So if we save that, I'm just going to drop it to my desktop. And let's see what we can see if we look at that. So in static analysis, we already looked at this program's strings, and we know what was and what was not there. And we know that savimpet.com, there was no domain in this program's static strings. Also, this looks a little bit interesting. This seems to be my host's name, I suspect. This Adobe update string. So it turns out this piece of malware was protecting some strings. It had them obfuscated in some way, which we'll learn later. And then it unpacked them into memory. And it left them sitting there, fortunately enough for us, so that when we went to memory and dumped the strings, we got more useful strings. We got the strings it was trying to protect. And there's some more up here. So yeah, that in-memory strings thing can be very, very useful. Let's go back to Explorer. You can also, some of the things we mentioned in lecture is if you turn on the lower pane view, so view, show lower pane, then you can see all sorts of interesting things. So we can tell it in the lower pane view whether we want to see DLLs or handles. So if we want to see all the DLLs that this process has loaded, then we will do that. And you can see all the libraries that this process has access to. And then if you want to see all the handles that this process has, then you can change lower pane view to handles, and you can see what files, registry keys, and things like that this process has obtained handles to modify. So these can be very useful. We're not going to dive too deep into those, but I want you to know of the capability. All right. So let's look at our regshot logs. I'm going to close that. So this is regshot. And there's only one thing in here that I'm particularly interested in. The registry has a lot of noise. This is a great thing to do the no normal type activity with. Just launch regshot, do some things, launch regshot again, and get used to what is noise. But as we scroll, the thing that really jumps out at me is a value added to this key. So we have WAL6432, so a compatibility, run key. We have Adobe update put in under it, and then we have this path to add data local temp to the Adobe update that we saw our malware write. This is interesting because anything in that run key is automatically executed on boot, and so this is a persistence mechanism for this malware. This is ensuring that when the computer boots, Adobe update.exe will run. This is the most common, most basic persistence mechanism that there is, especially if we narrow it down to the registry. And so that's all that I really wanted to point out here. So let's ask some questions. So I said we saw the malware write Adobe update.exe, but the truth is that we didn't really see the malware write Adobe update.exe. We saw Adobe update.exe appear and assume that it's the malware. So how could we prove that malware wrote Adobe update.exe? So let's go to Procmon. One of my favorite features of Procmon is the tools process tree. This gives us a process tree of everything that executed while we were capturing. And you can see our tree of evil.exe is pretty big mess. But it's an interesting big mess. So we see evil launches CMD, CMD launches Rundle, Rundle launches Rundle, Rundle launches sysprep, sysprep launches evil, evil launches Adobe Update. CMD executes a bunch of times. You can see the command that it's executed with down here. So ping localhost and delete evil.exe. Ping and delete cryptbase.dll. Ping and delete that .dat file. So we see evil launch Adobe Update.exe. What wrote Adobe Update.exe? So what I'm going to do is I'm going to close this tree and then go to Filter, Filter, and I'm going to say path is, and remember I copied the path of Adobe Update earlier, then include, add, apply, OK. And let's look at all of the actions that were taken on Adobe Update.exe. And so what we really want is a write file. There's our process create. Too far. There's our write file. And so we can see evil.exe performed a write file operation on Adobe Update.exe, and that is when that file was created and written. We can also see evil.exe performed a process create operation on Adobe Update.exe, and that's when that process was created. What are some other questions that we might want to ask about this sample? I don't want to run too far into our next lab. How about what deleted evil.exe? This is an interesting question for a couple of reasons. So again, we're going to go filter, filter, and we're going to say path is, what's my favorite? There are obviously a ton of options in here. Operation is a very useful one, but a lot of times if I'm pivoting off of my regfs notify stuff, then I'm going to be using path is. Then include, add. I'm going to uncheck this last one because I don't still just want to look for Adobe Update. I want to look for evil now. Apply. Okay. So evil.exe no longer exists. I scroll to the bottom because we're trying to figure out what deleted it, and that's one of the last operations that happened on it. And so it makes sense that it would be down here towards the bottom. And so what you can see is that a delete file is actually a set disposition information file call in which the details say delete equals true. So to delete a file, we're really just toggling a flag to make the file disappear from us. And so this is the file delete. You can see that that was performed by cmd.exe with the PID 2180. So again, if we go look at our process tree, we can see a process 2180 deleting our evil.exe. All right, I think that's a good enough overview of Procmon for this moment. We're not done with Procmon. We'll come back to it. But we wrote 2 filters and used it to answer a couple of questions. So let's go to our Wireshark. First off, Wireshark's going to have a decent amount of garbage too, because your Windows machine is making noise all the time, as is the software installed on it. If you're unlucky, Windows might have requested an update while you're running, which is always an adventure. So just look for your DNS request to salvimpet.com and work from there. So let's check out this TCP stream. So I'm going to right-click it, follow TCP stream. I just picked the TCP packet immediately following the DNS request. And you can see we're trying to post, and there's some information there. We noted this string was in our memory space. What I would suspect, my guess here would be that this is some system profiling information being sent out, and we would have to confirm that via some more in-depth analysis of the actual code. And so you can see it makes a post, and then inetsim says, hi, I'm an HTML page. You wanted HTTP? You wanted HTML? Here you go. It just serves whatever it can. So if we filter out that stream and then go to the next one, not the DNS stream, again, right-click, follow TCP, we can actually see a GET. And so this helps us understand what all of those temporary internet files were that we saw. So this is JVAT, Z, something or other. If we come back over here, if we look at our temporary internet files, oh look, same name. So the computer issued a GET request, the malware, issued a GET request for this photo. Again, I'm going to suspect that this is some sort of system profiling information. And inetsim said, oh, you want a JPEG? Here's a JPEG, and serves a JPEG, which then got written into the temporary internet files location. And one more. A GET for viewphoto.asp. And again, inetsim serves an HTTP page. So you can see inetsim trying to do whatever it's asked. And this just keeps happening over and over and over and over again. So that is a quick overview of a quick and dirty dynamic analysis of this sample. We still have a lot of questions that need answering, but the goal of this particular demo was just to introduce you to each of the tools, how they're used, and what they log. In a future demo, we'll actually get more in depth trying to figure out what was happening here.